All right, so this chapter is where we're going to deal with the different types of reactions that you're more likely to encounter in this course, all right? So I'm just going to go through it quickly because of course I expect that you have watched the videos. Yes, ma'am.
I wasn't here last class and I assumed we would be doing chapter 7, but it's not on campus,
Oh, you mean the
lecture.
video?
Yeah.
Oh, really?
Yeah.
Oh, hold on.
Oh, yeah, I didn't see a chapter 7.
Unless I just wasn't looking in the right spot.
Could be me. Let me check and see.
Oh, yeah, it's chapter 6.
You looked under the module section, right?
Yes.
Okay. Oh, you're right. Okay. So let me publish that now. I guess I'll have to talk more about it's not a long chapter. I'll just go through it and then you can watch the videos after to supplement whatever I discuss now. So basically in chapter 7, go back to the PowerPoint. So I apologize for that, folks. So the different types of chemical reactions we'll be looking at are combination reactions, decomposition reactions, single displacement reactions, and double displacement reactions. And there's a fifth category, which we're going to talk about later on, which would be the combustion reaction, right? So most of the reactions that you're going to encounter in this course will fall under one of these 5 categories, right? So let's talk about combination first. What do we mean by a combination reaction? A combination reaction is one where you have 2 or more reactions coming together to form one product, all right? So to use a hypothetical example here, A plus B to give AB, that would be your combination reaction. So to give some real examples, in some cases, metals will react with oxygen to form a metal oxide. So for example, you see here the reaction between calcium and oxygen to form calcium oxide, and aluminum and oxygen to form aluminum oxide. In both cases, you have 2 substances coming together to form one product, right? You can also have a situation where a nonmetal combined with oxygen to form a nonmetal oxide, such as in the case of sulfur and oxygen to form sulfur dioxide, or nitrogen and oxygen to form nitrogen monoxide. So those are also examples of combination reaction. And then we have a situation where you can have a metal combining with some other nonmetal other than oxygen to form what is called a salt. So an example of this would be the reaction between potassium and fluorine to form potassium fluoride, and the reaction between aluminum and chlorine to form aluminum chloride. Okay, and then we have in some cases, and this is not true in all metal oxide cases, but in some cases, you can have a metal oxide combining with water to form a metal hydroxide, such as the example that you see here, the reaction between sodium oxide and water to form sodium hydroxide, or the reaction between calcium oxide and water to form calcium hydroxide. You can also have a situation where non-metal oxide combines with water to form what is called an oxyacid, such as the reaction between sulfur trioxide and water to form sulfuric acid, and dinitrogen pentoxide reacting with water to form nitric acid, right? So again, these are examples of combination reactions. So the next group of reactions we're going to look at is what are called decomposition reaction. And these can be considered to be the reverse of what we just looked at in terms of combination reaction, where you start off with one reactant and you end up with more than one product. And usually I might add, this reaction or this type of reaction requires heat in order to get that reaction going, right? So basically, hypothetically speaking, AB is the reactant, and when it undergoes the decomposition, it forms A plus B. Okay, somebody's asking a question. Yes, I think I am recording to answer. Let me just check and make sure. If not, I will definitely okay. Let's see. Okay, it is recording, at least right now, all right? Okay, so going back to the PowerPoint. So this is decomposition. This is a hypothetical example. And then to get to some real examples, silver oxide, when heated, will produce silver and oxygen. And that's a case of a metal oxide breaking down to form a metal and oxygen. You can also have a metal oxide breaking down to form another metal oxide and oxygen, such as the heating of lead 4 oxide to form lead 2 oxide and oxygen. All right. Also, some carbonates, when heated, will decompose to form carbon dioxide, such as in the case of the heating of calcium carbonate to form calcium oxide and carbon dioxide. And in some cases, hydrogen carbonates will break down when heated to form a carbonate, water, and carbon dioxide. And then there are some other reactions that we can point to as decomposition reactions, such as the decomposition of hydrogen peroxide. Hydrogen peroxide, if you leave it open to the atmosphere long enough, then it will decompose to form water and oxygen. And I think I have another example here, the heating of potassium chlorate to form potassium chloride and oxygen. So these are all examples, another one here. So these are all examples of decomposition reaction where you're starting off with one reactant and you're going to end up with more than one product. Okay, then we have single displacement reactions. And basically what happens in these reactions is that one element reacts with a compound to replace one of the elements of that compound. So in other words, let's say you have element A here, and it reacts with a compound which is a combination of element B and C. Then what will happen if this is a single displacement reaction is that A will displace B. All right, so A is going to take the place of B, end up being combined with C, and you're going to end up with AC as one of the products, and B being the other product as a result of its displacement. All right, so that's what happens in a single displacement reaction. All right, so a good example of this is this reaction here. If you take a piece of magnesium metal and you put it in a solution of hydrochloric acid, then you're going to see bubbles being produced. And those bubbles will be due to hydrogen gas being formed. And that hydrogen comes about as a result of the magnesium displacing the hydrogen, right? So therefore, the magnesium will now end up combined with the chloride to form magnesium chloride. And the hydrogen, of course, would be produced as hydrogen gas. And this is called a salt, by the way, the combination of the magnesium and the chloride. Another example here, if you take aluminum and add it to sulfuric acid, again, a displacement will take place where the aluminum will displace hydrogen, and you're going to end up with hydrogen being formed along with aluminum sulfate, which is the result of the displacement of the aluminum, aluminum displacing the hydrogen. Excuse me. Okay, so that's, or those are examples of single displacement reaction. Here's another one. Now this one tends to take place with more active metals, like the metals in group 1A and group 2A. If you add them to water, then in some cases you get a violent reaction, especially if you look at group 1A, I'm talking about elements like sodium, potassium, rubidium, and cesium. If you take a small piece of those metal and put it in water, you're going to get a very explosive reaction, a lot of heat generated. And what is happening in these reactions is the metal, in this case sodium, will displace hydrogen to form sodium hydroxide, all right, which is a metal hydroxide. Another example, now this one is not as vigorous. In fact, you'd have to heat this one to make sure it goes. But again, this is another example of a displacement reaction. A single displacement reaction where the calcium is displacing hydrogen to form again another metallic hydroxide, which in this case would be calcium hydroxide. All right. So that's what happens in these cases. In some cases, less reactive metals like iron, and you have to heat this to make sure that this goes. You can have the displacement of hydrogen, but this time it's going to form a kind of unusual oxide here, commonly known as tri-iron tetraoxide. It's actually a combination of two substances here, actually. It's a It's a combination of, write this down here. It's a combination of FeO and Fe2O3, right? It's kind of unusual, but there's a strong association between these two compounds to form this one entity, all right? But in any case, this is another example of a single displacement reaction where iron is displacing hydrogen and it ends up being combined with oxygen in the form of these two compounds together, all right? Okay, another example. Oh, I thought I had another example. Okay, now one thing I want to talk about specific to the single displacement reaction is that in some cases, you can predict basically whether or not the reaction will take place according to what is known as an activity series, which will help you to do that. Now, what do we mean by the activity series? The activity series is basically a list of different metals, and hydrogen is included in this list, which basically is ordered according to their reactivity, right? So this is the activity series, and in fact, if I'm not mistaken, this is not a complete activity series, but it's a good representative list of different metals and the order of their reactivity. So the way they're ordered here is that you're ordered with the most reactive metal at the top, and then the reactivity decreases as you go down. So basically, we can use this to make predictions as to whether or not a particular type of single displacement reaction will take place. And the way we use this is basically indicated in this sentence right here. It says an atom of an element in the activity series will displace an atom of an element below it from one of its compounds, right? So basically, for example, if you choose any two, let's say, okay, so let's say, since I have it here, let's say we choose sodium, right? If you react sodium with any compound that contains any one of these elements below it, then the sodium will displace it. And I think I have an example of it here. So for example, this case here, right? Magnesium, let's say you're asked the question, will this reaction take place? The reaction between magnesium and lead 2 sulfide to form magnesium sulfide and lead, right? So you consult the activity series and you see the relative positions of magnesium to lead. So magnesium is here, lead is down here. So therefore we know that magnesium, because it's above lead in the activity series and is more reactive, that means that we can say yes, magnesium will displace lead to form magnesium sulfide and lead. All right, so that's basically how we can use the activity series in order to make these kinds of predictions, right? Now here's another example. In this case, the reaction will not take place, and we can predict that because of the relative positions of silver to copper, right? Here is silver and here is copper, right? Silver is below copper, so that means that silver is not as reactive as copper. So therefore, silver will not displace copper from copper to chloride, so therefore there will be no reaction that will take place. The other way would be true actually. If you had copper and you're trying to react it with silver chloride, then that reaction will take place. You're going to end up with CuCl2 plus copper, because again, silver is here, copper is here. That means copper is more active or more reactive. And therefore, copper will displace silver from your compounds. All right? Okay. Now, within group 7, which is the group of elements known as halogens, that is in and of itself its own activity series, because what you'll find is that the activity decreases as you go from top to bottom of that group, right? So what that means is that fluorine is more active than chlorine, which is more active than bromine, which is more active than iodine. We usually ignore astatine AT because it is, oh shoot, okay, yeah, the Zoom connection is lost. What's going on here? Let's see. Oh, Wi-Fi stuff. Okay, I don't. Okay, I don't know if you guys, out there in Zoom, what you missed or if you missed anything, so I apologize for that. The Wi-Fi here was down. While I was talking. I'm just going to continue from where I left off, and I'm hoping that the recording catches everything that I've taught so far, so you can go back to that and rewatch it. Okay, so I was talking about the fact that in group 7, that in and of itself is an activity series where the activity of the elements in that group decreases as you go down. So fluorine is the most, let me share my screen. Fluorine is the most active. Right, fluorine is the more active, followed by chlorine, followed by bromine, followed by iodine. So therefore, we can use that series to make predictions such as whether or not this reaction will take place, right? So basically what we're trying to see is whether or not chlorine will displace bromine, and the answer is yes, because chlorine is above bromine in that series, right? So therefore, chlorine will displace bromine, and you're going to end up with these as your products. So that's basically how that particular activity series can be used to make predictions as to whether or not a particular semi-displacement reaction will take place. All right, so let's talk about another group of reactions known as double displacement reactions. And in the case of double displacement reactions, what you have basically is an exchange of partners. This typically takes place in a reaction where you have two ionic compounds that are reacting with each other, right? So you all know that ionic compounds contain ions, right? One positive, one negative, right? So if you have two of these compounds, there exists a possibility in some cases where you have an exchange of ions, and therefore you're going to get a particular product outcome arising from that. So let's say one ionic compound is AB, the other ionic compound is CD, then there's a switch of partners where A ends up with D and C ends up with B. So you're going to end up with A displacing C and combines with B, and C will end up being combined with B, and you end up with your products shown on the other side. This is just showing you what is displacing what, and you're ending up with your two products on the right side of the equation, right? So that's what happens in single displacement reactions, all right? Now, there are several things that you'll observe when it comes to these types of reactions. You'll end up with what is called a precipitate being formed, right? Now, I don't know if you've met this term before, but a precipitate is basically a solid that is formed when you mix two solutions together. So if you have two clear solutions, right, and you add them together and you end up with a solid being spontaneously formed, then that is called a precipitate. And that reaction is called a precipitation reaction. Another thing that you'll observe with these reactions is the formation of gas bubbles. And we're going to see some examples of that shortly. And then another example is that you may not see any visible change, but you'll see or observe, I should say, release of heat. So in other words, if the reaction were to be done in a test tube and you feel the outside of the test tube or beaker or whatever the vessel is, then it's going to feel warm, right? And the term we use to describe that, we say that these reactions are exothermic, which means that they produce heat, all right? Another thing that is observed in some of these reactions is the formation of water, H2O being formed, all right? So let's look at some examples. The first example we're going to look at is what is called acid-base neutralization. So in the case of acid-base neutralization, it's the reaction between an acid and a base. Now, we have not met these terms yet. I think we're going to meet them later on. So I'm just going to give you a brief introduction as to what an acid is. An acid is, well, here's an example of an acid, hydrochloric acid, right? An acid is basically a substance where you have hydrogen bonded to a nonmetal in most cases, right? And then a base is a substance which produces hydroxide ions. So some of them contain hydroxide ions, such as sodium hydroxide, right? So this here is what we call an acid-base neutralization reaction, where you have an exchange of ions, right? So what will happen is that the hydrogen is going to displace the sodium, and when that hydrogen displaces the sodium, you're going to end up with water being formed, and at the same time, the chloride is going to displace the hydroxide, and you're going to end up with sodium chloride being formed as a result of that, all right? So that's an example of a double displacement reaction, and specifically, this is an acid-base neutralization reaction. Here's another example, the reaction between sulfuric acid and water. Same thing's going to happen. The hydrogen here is going to displace the sodium to form the water that is formed over here, and the sulfate is going to displace the hydroxide to come back with the sodium to form the sodium sulfate right here, right? So that's what happens in this type of reaction. Okay, so that's an acid-base neutralization reaction, which is a type of double displacement reaction. Now, here's an example where you have what I mentioned before, the formation of a precipitate. A precipitate is a solid that is formed, as I said before, when you mix two solutions together. So in this case, you were mixing two solutions. One of them is silver nitrate, and the other one is sodium chloride, right? And what you'll find if you were to mix these two, if you were to do that experiment in the lab, you're going to see a solid white precipitate being formed, right? And that white precipitate is silver chloride, and the other byproduct is sodium nitrate, which remains in solution, right? So this product is formed as a result of the silver displacing the sodium, right? You end up with silver chloride, and the sodium nitrate is formed when the nitrate displaces the chloride to form sodium nitrate. So that's an example of a reaction, a double displacement reaction, where a precipitate is formed. I think I have another example here. Now, in this case, you're mixing lead nitrate with potassium iodide. And again, you're going to end up with a precipitate here. Now, the color of this precipitate is yellow. So in this particular case, and these two solutions, by the way, are clear, all right? Colorless and clear. Well, no, not this one. This one has, I think, a kind of pale yellow color. But in any case, what will happen is that the lead will displace the potassium to form the lead iodide, which would be the precipitate that you visibly see being formed out of solution. And then the nitrate is going to combine or displace the iodide to form potassium nitrate, and that will remain in solution. So these are examples of precipitation reactions, which are, of course, double displacement reactions. You can also have a double displacement reaction, where a metal oxide reacts with an acid, as you can see in this case here. Copper 2 oxide reacting with nitric acid to form copper 2 nitrate as a result of the copper displacing the hydrogen, and the oxygen displacing the hydrogen to form the water, all right? Here's another example, calcium oxide reacting with HCl, pretty much similar to what we see above. The calcium displacing the hydrogen, the oxygen displacing the chlorine, and you end up with your products on this side, all right? Now, in terms of gas formation, there are some examples that I'm going to show you here. The first of which is one where if you're in a room with this reaction taking place, you need to get out quickly because this gas is very toxic. Hydrogen cyanide, right? So sulfuric acid, if you add it to sodium cyanide, then basically what will happen is that the hydrogen will displace the sodium to form the hydrogen cyanide, and the sulfate will displace the cyanide to form the sodium sulfate. All right, so that's basically how that works. Here's another example, the reaction between ammonium chloride and sodium hydroxide to form sodium chloride and ammonia. So basically what's going to happen is that the ammonium will displace the sodium to form the ammonium hydroxide, and the chloride will displace the hydroxide to form the sodium chloride. Right? So that's what happens. Now, this is not a gas, but this here will actually break down to form a gas. So another equation demonstrates that right here. Ammonium hydroxide will decompose. Remember that first type of reaction? Well, that's what's happening here. You have the decomposition of the ammonium hydroxide to form ammonia and water. All right? Okay. So indirect gas formation is taking place here. Okay. Not quite the end yet, because there's one other category of reaction that was not covered in the PowerPoint, and that would be combustion reactions. So let me just quickly talk about that. Now, there are a group of compounds. I don't know if you're familiar with this term, organic, in chemistry. In chemistry, when we're talking about organic compounds, organic compounds are compounds of carbon. All right, and that's a separate broad discipline of chemistry. All right, now there are a few exceptions of carbon compounds or compounds containing carbons that are not considered to be organic. So let me just make a note of those exceptions. You have carbon exceptions. You have carbon dioxide, carbon monoxide, carbon disulfide, anything that contains a carbonate ion or bicarbonate ion. So this is bicarbonate. This is carbonate. And I think there's one more. What am I missing? Carbon dioxide. Oxidant. C2O42 minus. Okay, so pretty much all other compounds which contain carbon are considered to be organic, right? But these are the exceptions, right? Now, the thing about, and you have within that large group of organic compounds, you have various types of organic compounds. What I'm going to talk about specifically are two types of organic compounds. One type, which are known as hydrocarbons. Hydrocarbons. And hydrocarbons contain carbon and hydrogen only, right? So some examples of hydrocarbon compounds would be like methane, CH4, ethane, C2H6, benzene, which is C6H6. These are all called hydrocarbons because they only contain carbon and hydrogen. The other group of organic compounds we're going to talk about, there's no special name for them, but these are basically compounds containing carbon, hydrogen, and oxygen, right? So this discussion about combustion will be dealing with only these groups of compounds, hydrocarbons and compounds containing carbon, hydrogen, and oxygen. Now, combustion, what is combustion? Combustion is basically a fancy term in chemistry that we use to say burning, right? So you subject the substance to a flame and it burns, right? And that's a chemical reaction, right? Now, when you burn or combust hydrocarbons, what always happens, so I'm just going to use this to represent hydrocarbon, right? When you burn them in air, they react with oxygen, right? And the products will always be CO2 plus H2O, right? That's assuming that the combustion is complete. If the combustion is incomplete, then you may end up with carbon monoxide or you may end up with carbon, right? But if you completely burn your compound, right, which contains carbon and hydrogen, then the products will always be carbon dioxide and water. And it turns out that if your compound contains carbon, hydrogen, and oxygen, the same thing is going to happen. You're going to get CO2 and H2O, all right? So that's the fifth category of reaction that we're discussing in this chapter. Combustion of certain organic compounds, hydrocarbons and compounds containing carbon, hydrogen, and oxygen. When you burn them, you're going to end up with carbon dioxide and water as your product. All right? So that's basically it as far as the different types of reactions are concerned. So what I'm going to do now is give you assignment number 7 to start working on. And basically what you'll be doing, at least for the first part, in part A, you'll be balancing the equations, right? And then you will be indicating on the right the type of reaction that equation represents. And for those of you out there in Zoom, I'm going to publish, this assignment right now. Okay. Oh. Okay, so let me help you with maybe one or two of these, right? So basically in section A, you're given unbalanced equations on the left, right? And then it says you are to tell what type of reaction or what category the reaction falls under. Turn on my pen. Okay, so for the first one, how would you go about balancing that equation? Number one, in section A.
Put a 2 in front of the aluminum and a 2 in front of the aluminum and nitrogen, or what is that? On the far end?
The aluminum nitride on this side.
Oh.
Yeah, all right, so that's it, right? And then what type of reaction would you, what category would you put this under in terms of type of reaction? Combination, exactly. Okay, what about the next one? How would you balance this? Okay, 3 here, okay. And what type of reaction is this? Combination again, yeah? Okay, very good. Okay, what about the third reaction?
Sorry.
Already balanced, right? So what type of reaction is it? Decomposition. Okay, next one. How will you balance this one?
Water.
Okay, I would agree with that. And what type of reaction is this? Decomposition. Okay, very good. What about number 5? How will you balance that equation? Number 5. Two in front of the potassium iodide, two in front of the potassium chloride. And what type of reaction is this? Single displacement. All right. And then we get to number 6. How would we go about balancing this equation? I'm sorry? Okay, 2 here, and then what else?
You're gonna need another 2 in front of the hydrogen nitride oxide on the far right,
We call it nitric acid, right?
nitric acid.
Okay. Good, so now the equation is balanced, so what type of reaction would you say this is? Double displacement, very good, double displacement. Okay, and then we get to number 7. How do we go about balancing this equation?
Two in front of barium oxide.
2 in front of the barium oxide.
Yeah, two in front of the other barium oxide.
Oh, this is barium peroxide. And I think that's it, right? Yep. Okay, what type of reaction would you say this is? Decomposition. Okay, very good. All right, so I'm going to leave you guys to do the rest. Oh, somebody has a question? Oh, I thought I did, Miss Jones. Let me check and see. It's right here. It's published as far as I can see. Miss Jones, I don't know. I don't know what's happening on your end. Oh, okay, all right, no problem. Happens to the best of us. All right, so basically, do the others. You're free to leave if you want to, but I'll be here for the rest of the class. But before you leave, let me just say that your next test, I'm kind of trying to weigh whether or not it's scheduled for next week, but I'm trying to weigh whether or not I should put it off until the other week, only because I'm trying to catch up with grading your assignments numbers 5 and 6. Because the next test will be based on chapters 4, 5, and 6. However, I've already graded 4, but I need to grade 5 and 6 and get it back to you guys so that you guys can have it to review. So I'm hoping to get that back graded by the end of this week. So what I'll do is I'll make an announcement as to whether or not the test will still be on for next week. And if not, then I'll tell you exactly what's going to happen. More than likely, otherwise it would be the week following. Right? So that basically it. Yes, sir.
For the activity series,
Uh-huh.
are we given that? Or do we-
Yeah, I want to provide that to you, yeah. I want to provide that to you. Okay, so that's pretty much it. Now, who was it I said I wanted to talk to? Fitzsimmons, are you still there?
Yes, sir.
Yes, so apparently you were given the wrong test when you went to the testing center.
Yeah, I kind of found that out after I saw that there was balancing equations on, and I'm like, I don't think we covered that yet. I mean, I knew how to from previous chemistry courses, but I was a
So,
little suspicious on that.
yeah,
So,
so basically, I didn't realize it until I was dealing with the other class for which that test was for. Right?
okay. I was
Uh,
wondering.
Your paper with your name and that name was not on that class list. And then I realized it was, you were in another class, which is this one, right?
Mhm.
So the only thing I can suggest is that you can come by my office at, you know, during my office hours, depending on the campus, which campus you think is, more convenient, because I'm between here and the Ocala campus.
I am at the Ocala campus, so
Okay, so if you're at the Ocala campus, I'll be, if you want to do it this week, today's what? Today is Tuesday. Okay, I will be in my office tomorrow from 2 to 5,
okay.
or Friday from 2 to 5.
Let's shoot for Friday
Okay, no problem.
around 2, if that works
Alright.
for you.
Now, what I want you to do for me is to send me an email on Thursday to remind me. Because I
Okay.
will, right, just shoot me an email, remind me of the test, and then I'll get that prepared for you so that you're ready to do it on Friday.
Okay. Thank you very much.
All right, take care.
All right. Thank you.
I have a question for
For which one?
13.
13.
Would this be question?
Well, 1 minute. Okay, 13. Yes, that would indeed be combustion.
This going to be carbon.
Right. Oxygen plus a hydrocarbon to give you carbon dioxide and water.
Okay.
Right. That's combustion. Yeah. What, I'm gonna set above. Problems. Let's see. Oh, Miss Chan, hold on, okay, Chan Sui, are you still there? Oh, he left. He said that they gave him the wrong testament. Oh, well. What is going on over there?
So is this the last chapter before the test?
I'm sorry?
Is this the last chapter before the test or?
I haven't decided yet. I know that the test will cover 4, 5, and 6. I'll let you know before this week is out whether or not this chapter will be on it. But for sure, 4, 5, and 6 is going to be on the test.
Okay,
I'll let you know.
and the test is next week?
Well, again, yeah, depending on how things work out before this week is out.
Okay,
Just going to post an announcement. I would say definitely by Friday morning, I'll post an announcement and let you guys know exactly what the deal is.
okay,
All right?
thanks, bye.
Yes, sir. 11. All right. Let me see here. 11. Okay, this one?
Yep.
Okay, so that would be, well, first you have to balance it. So to balance it, you're gonna need a 2 here, and a 2 here, and a 2 here, right? 2 sodiums, 4 hydrogens, 2 plus 2, 4 hydrogens, 2 oxygens, 2 oxygens. Okay, so the question now is what type of reaction is it? Well, the sodium here is displacing some of the hydrogens, not all of them, right? But some of the hydrogen being displaced. So this would be a single displacement reaction. All right? All right.
When is the due date for the homework?
I've just, to answer your question, Ms. Bethencourt, I just, created a Dropbox with the deadline being, on the 9th, which would be Thursday.
Thank you.
Hmm? All right, very good.
How you been?
Pretty good.
Good.
Not doing so hot in this class. I guess 79.
For camp?
This is intro.
You're taking intro?
Yeah.
Oh, I didn't know that.
Yeah, it's a little tough.
I'm in camp one now.
Yeah, take it the next semester.
I took the intro during summer.
Yeah.
I took that math class we had taken and then the intro. Hey, I didn't. Well, I meant to ask you, how'd you do on that?
On what, math class?
Yeah.
That was that college algebra?
The college level.
I did fine. I think I got a C.
A C.
That's fine, it's math. I'm doing better in my recap class though. I got an 87.
Oh, nice job.
I don't know, I guess it worked out.
Yeah, it was hard work, man.
Yeah.
Hard work. Yeah. I have in biology, we used to hold around in biology lab, 1 and 2. And you got that shit back to back. He's doing the same path I'm doing, but he's doing he's going to be a are you that question was 1 3? Check the percent of thing. That's not like the questions. I think percent.
Okay, I'm gonna sign off now from Zoom.